Good morning to all. In the process equipment design, we discussing the types of jacket, various types of jacket. So there is a numbers of types of jackets are available, and the jackets are used for the based on their applications. Okay, so in which we discussing a channel type jacket and try to discuss about the design. So today's topic is design of the jacket. So there is a numbers of types of jackets available, but most common is channel jacket as well as spiral buffel jacket. Okay, so spiral buffel jackets are the most heat transfer coefficient having, and the velocity is more at that jacket. So now let's do the first the design of channel. Before it, let's recall it. Spiral buffel jackets offer three advantages. First one is that is the it is decrease the flow area. So the main advantages is that increase the velocity increase and heat transfer coefficient is increasing. Here buffel as act as a fin and increase the heat transfer area. Buffel act like a fins. And third one is that the buffels stiffening ring. Buffels also react as a stiffening ring, so which is support the jacket. Okay, now the design of channel jacket. The channel jacket is shown in figure B. Okay, so B is the uh, channel jacket. So thickness of shell is given by these equations. If there is need to require the thickness, how should be the minimum thickness for the channel jacket? Okay, so thickness of shell is given by equation. It is TSD under root K1P upon F1 plus C, and thickness of channel is given by equation. Thickness of channel and the above one is the thickness of shell. वो शेल का थिकनेस है और ये थिकनेस है चैनल का. ठीक है, विच इज गिवन बाय टी सी डी अंडर रूट K2 by P upon F2 plus C. Now, so the various parameters shows in figure. So here is figure 5.6 is channel jacket. So D is what exactly meaning for that? D is exactly the meaning of that जो curvature है, curvature that means half coil, वो उसे कहेंगे D. ओके, तो उसकी लेंथ क्या कंसिडर करनी है? देन टी सी इज द चैनल थिकनेस एंड टी एस इज द सेल थिकनेस. ओके, पी इज द इंटरनल डिजाइन जैकेट प्रेशर. F1 मैक्सिमम अलोएबल स्ट्रेस ऑफ सेल एट अ डिजाइन टेम्परेचर सेल का. और F2 क्या है? स्ट्रेस मैक्सिमम अलोएबल स्ट्रेस ऑफ जैकेट मटेरियल एट अ डिजाइन टेम्परेचर. K1 and K2 both are constant, so take its value as a 1.0.167 and K2 is 0.12. Then after C is corrosion allowance, take as a, and TS is the cell thickness in addition to internal pressure. A thickness of shell should be checked for jacket pressure. Okay, and TC is for thickness of channel. Okay, so these are the design equations which is following. Then next one is design of half coil jacket. Half coil jacket E1 is describe that. So E જે છે એ શું છે? હાફ કોઇલ જેકેટ. તો એ પ્રકારનું જ્યારે જેકેટ યુઝ કરીએ તો how it should be take as a. So figure 5. Figure B is indicating that the another type which is shown in figure, which is known as a overlapped cut coil. ऊपर overlapped cut coils है और E is the half coil. Okay, there is in figure design of half coil. So in figure, half coil jacket with welded shell સાથે આ રીતે પણ થઈ શકે છે. સો ડિઝાઇન ઓફ હાફ કોઇલ જેકેટ. સૌથી પહેલાં તો હાફ કોઇલની ડાયામીટર કન્સિડર કરવાનું, પછી કોઇલ જે જેકેટ છે એની થિકનેસ લેવાની, એટલે કે ચેનલ થિકનેસ લેવાની, અને thickness for the cell similar up to above. So design of half coil jacket. So circumferential stress induced in coil at the junction of coil and the shell is given by the equation FPC is equal to PDI upon 2C days, and longitudinal axis stress induced in coil is given by equation F of SE is equal to PDI divided by 4TC dash plus 2.5 TS dash. Okay, so FPC is equal to PDI upon 2C dash. P is the internal design pressure, DI is the diameter of coil, and TC is the channel thickness. Okay, and TS is the cell thickness. So P is internal design of inside half coil, DI internal diameter of half coil, DI is the internal diameter. Okay, then TC dash is the thickness of half coil excluding corrosion allowance. Okay, so now this word it said that thickness of coil without excluding, that means without corrosion allowance. क्या corrosion allowance उसके अंदर ऐड किया नहीं है. Same for the cell, thickness of cell excluding corrosion allowance. Okay, and T dash, thickness of half coil is determined by the equation T only. So TE is equal to PDI upon 2FC plus CA, where CA is the corrosion allowance. Okay, CA is corrosion allowance, and total circumferential stress induced in the cell, FES is sum of circumferential stress induced in the cell due to the internal pressure and FSE. So write down the both equation. FPS is equal to FP, that is P dash DI, and divided by 2 TS dash plus PDI upon 4 TC dash and 2.5 TS dash. Okay, where P dash is internal design pressure for cell, and P is coil inside internal design pressure. Now, due to the coil side pressure circumferential stress induced in the cell in addition to circumferential stress induced by the inside pressure. This additional circumferential stress in the cell is equal to the longitudinal stress induced in the coil. Total longitudinal or axial stress induced in cell is given by equation FAS is equal to FA plus FPC plus FB. So FAS is equal to P dash DI upon 4 into TS dash plus PDI upon 2C dash plus 2 delta P D0 square upon TS square. Okay, total FAS, total longitudinal or axial stress. Okay, and then the formula is said that FAS P dash DI. So P dash की वैल्यू, P dash का मतलब क्या होता है, सेल इनसाइड डायमीटर, इनसाइड प्रेशर डिजाइन, इनसाइड डिजाइन प्रेशर, और खाली P coil side internal design pressure. DI inside diameter of coil, DI inside diameter of coil. Delta P is the maximum pressure difference between coil and cell. D0 external diameter of coil. TS thickness of shell excluding corrosion allowance, and the FB is the bending moment stress caused by the distortion of shell at the junction with the coil. Once we find out the thickness of coil, thickness of shell should be determined by equation which gives the thickness of shell excluding of CA. Hence, to which we have to add CA, then thickness of shell should be checked for longitudinal stress. And preferred range of half coil thickness is ranging from 0.3 to 1.2 times of the thickness of the shell. Okay. So here is the design of the jacket, coil jacket, half coil jacket, and channel jacket. Okay. Here the unit that is over here. Okay. So example is remaining for this unit, but the pressure design of the vessel. So the design of the pressure vessel is unit is chapter over here. Now, so the next topic of your next unit of your syllabus is that is silent tube heat exchanger. So basically the silent tube heat exchangers and various types of silent tube heat exchangers already you are learned in the previous semester in the PD 1 subject. Okay, process equipment design 1. In this process equipment design 2 subject, there is a design parts are available. Okay, in the previously there is a types are available in this, and in this semester in the PD same some parts like as a various parts of silent tube heat exchanger already you are learnt in PD1. Then what is the particular part like spacers, tie rods, what is buffels, what is tube, what is cell. Okay, so basically this is as this one is also asked in a GTU, but we have to mention here main part is that the design part. Okay, and also some also we learnt about some symbols and the standards about the design of the heat exchangers. Okay, so the unit number, this one is the 6th in the book. Okay, so silent tube heat exchanger, okay, or it is called heat exchanger HE, are designed per TEMA diagram. So TE, the full form of the TEM is Tubular Exchanger Manufacturing Associations. Okay, so these are the standard for the heat exchangers. Okay, so silent tube heat exchanger are designed for TMA diagram or as per the standard Indian standard 4503. Okay, Indian standard 4503. And mechanical design of silent tube heat exchanger is done based on ASME code, but the mechanical design of standard American standard is ASME code. Okay, American Society of Mechanical Engineers, and Indian standard 2825 for unfired vessel. Okay, so this coding is important for the designing and the standard design. TEMA or Indian standard 4503 specify all linear dimension of silent tube heat exchanger, like a maximum allowable base buffel spacing, standard size of a shell, standard size, standard thickness of the tube, minimum tube seat thickness, buffels thickness, size of tie rod, numbers of tie rods. Okay, all these things. Now in the actually practice, Indian also fabricators and designers use TEMA standards and ASME standard. Okay, so both are standard codes. So today most popular software used for the process design of silent tube heat exchangers are HDRI, HDFS and BJAC softwares to develop the or the design of the silent heat tube exchanger. So what is the HDRI? So HDRI is the Heat Transfer Research Institute, USA based institute. HDRI, Heat Transfer Research Institute. Okay. Then HTFS, Heat Transfer Fluid Flow Services in the UK, and the BJAC is the USA based company. Okay. So these design methods are available in open literature. Design method is already open. So the all the other parts of the silent tube heat exchanger we discussing in the next lecture.